The world of science is abuzz with news that feels like it has been lifted from the pages of a futuristic novel. As of today, May 23, 2025, Google has unveiled a quantum computing chip, codenamed Willow, that promises to be utterly revolutionary. Unlike classical computers that store information as bits, representing either a 0 or a 1, quantum computers use qubits. Thanks to a quantum phenomenon called superposition, a qubit can represent 0, 1, or a combination of both simultaneously. This ability allows quantum computers to explore a vast number of possibilities at once. Google's Willow chip, however, appears to be more than just another step on this long journey of quantum exploration. Early reports and analyses suggest it is a significant breakthrough, a quantum leap in its own right. Therefore, this essay will embark on a journey to explore the multifaceted implications of Google's Willow. The centerpiece of Willow's incredible debut is a specific computational task known as random circuit sampling, or RCS. According to reports, Google's Willow chip successfully performed an RCS computation on December 9, 2024. The specific task involved complex calculations that, while abstract, serve as a crucial measure of a quantum system's capability to handle intricate quantum states and operations. To put Willow's achievement into perspective, the RCS computation was completed in under 5 minutes. Estimates suggest that even the most powerful classical supercomputers would require an astonishing 10 septillion years. This isn't just a marginal improvement, it's a fundamental shift in computational power, a demonstration of what is termed quantum supremacy. One of the most mind-bending theories in physics is the many-worlds interpretation, MWI, of quantum mechanics. In essence, MWI suggests that every time a quantum measurement is made, the universe itself splits into a multitude of parallel universes. How does Google's Willow chip connect to this seemingly fantastical idea? The extraordinary computational power demonstrated by Willow has led some prominent figures in the field to suggest a fascinating explanation. Hartmut Neven, the founder and manager of Google's Quantum Artificial Intelligence Lab, has reportedly suggested that Willow might be leveraging computations occurring across these parallel universes. The idea is that the vast number of calculations needed are, in a sense, distributed across countless other realities, with the final answer emerging in ours. The renowned physicist David Deutsch predicted decades ago that if quantum computers were ever to become powerful enough, their operation might provide evidence for the many worlds interpretation. Willow's performance seems to align intriguingly with Deutsch's prescient vision, lending new weight to his theoretical arguments. If Willow's incredible speed is indeed a result of tapping into parallel universes, then it's not merely a revolutionary computer. One of the most formidable challenges in the quest to build practical, large-scale quantum computers has always been the problem of quantum decoherence and the resulting errors. Qubits, the fundamental building blocks of quantum computers, are incredibly delicate. They exist in fragile quantum states like superposition and entanglement, which are easily disturbed by the slightest interaction with their environment. This noise causes the quantum information to degrade, leading to errors in computation. However, Google's Willow chip appears to have made a monumental breakthrough in this critical area: quantum error correction. Reports indicate that Willow incorporates a novel system capable of significantly reducing these error rates. The ability to actively detect and correct errors as they occur in a quantum system is paramount if we are ever to build fault-tolerant quantum computers. Willow's architecture, tested on grids of 3x3, 5x5, and even 7x7 qubits, demonstrates a pathway to building larger, more stable quantum processors. The findings related to this significant error reduction have been deemed so important that they were published in the prestigious scientific journal. The significance of this breakthrough in quantum error correction cannot be overstated. Section 5. The promise of Willow applications across the scientific spectrum. With its unprecedented computational power and significant advancements in error correction, Google's Willow chip opens up a breathtaking vista of potential applications across a vast range of scientific disciplines. The Google Quantum AI team has explicitly stated its ambition to perfect systems like Willow for critical future applications that could profoundly benefit life on Earth. In the field of medicine and healthcare, the impact could be truly revolutionary. Quantum computers like Willow could simulate molecular interactions with an accuracy and speed far beyond classical methods. This would dramatically accelerate drug discovery and development, allowing scientists to design novel therapies for diseases like cancer, Alzheimer's, or viral infections. Furthermore, understanding the complex dynamics of biological systems could be significantly advanced, leading to new insights into life itself and better ways to combat illness. In artificial intelligence, quantum algorithms could lead to more powerful machine learning models. Environmental modeling could see a huge leap forward, with quantum computers providing far more accurate climate change projections and helping to design solutions for sustainability. Section 6. Our Place in the Cosmos. Philosophical Quandaries of the Multiverse. If the performance of Google's Willow chip genuinely hints at the existence of the multiverse, as some interpretations suggest, then we are forced to confront some truly profound philosophical questions. The many worlds interpretation, if substantiated even indirectly by such technological advancements, would necessitate a radical shift in our worldview. One of the most immediate challenges is to our traditional understanding of identity and uniqueness. If there are countless parallel universes, each containing a version of ourselves, then what does it mean to be me? Are all these versions equally real? Furthermore, the multiverse theory has significant implications for concepts like free will and the nature of time. These are deep, existential questions that Willow's success, intentionally or not, brings to the forefront. Section 7. The Quantum Race, Cybersecurity, and Global Competition. While the scientific and philosophical implications of quantum computing, particularly a chip as advanced as Willow, are captivating, there is also a more immediate and pragmatic concern: cybersecurity. Most of the encryption methods that protect our sensitive data rely on mathematical problems that are too difficult for classical computers to solve in any reasonable time frame. However, these problems are potentially vulnerable to quantum algorithms, such as Shor's algorithm. This potential vulnerability has ignited an intense global race for quantum supremacy. Google is a leading player, but it is by no means alone. Other major technology companies, including IBM, Amazon, and Microsoft, are also investing heavily in developing their own quantum computing hardware and software. The nation or entity that first develops a large-scale, fault-tolerant quantum computer could hold a decisive edge in numerous domains, from intelligence gathering to economic power. In response to this looming cryptographic threat, there is a significant global effort underway to develop quantum-resistant cryptography. The development of powerful quantum computers like Willow serves as a stark reminder that the era of quantum vulnerability is approaching. Section 8. The next evolution: hybrid AI systems and a new technological epoch. The future of advanced computation is unlikely to be purely quantum or purely classical. Instead, it will almost certainly involve a sophisticated synergy between the two. This leads us to the exciting prospect of hybrid AI systems. Such systems would intelligently combine the distinct strengths of classical computers with the unique capabilities of quantum processors. Willow, if it becomes accessible and scalable, could be a cornerstone of this new hybrid approach. Imagine AI systems where classical algorithms manage data input and output, while offloading specific, computationally intensive subroutines to a quantum coprocessor like Willow. This integration could unlock levels of performance and problem-solving capability that neither technology could achieve on its own. Section 9. Beyond the Horizon. Willow's enduring legacy for science and humanity. Google's Willow chip is far more than just an impressive piece of engineering or a faster calculator. It stands as a potential catalyst for profound and far-reaching changes, a technological marvel that forces us to confront new scientific frontiers and deep philosophical questions. Its reported capabilities, from raw computational power to breakthroughs in error correction, signal that quantum computing is maturing at an accelerated pace. The broader impact on science could be immense. If Willow's operations indeed provide tangible, albeit indirect, evidence supporting the many worlds interpretation of quantum mechanics, it would revolutionize fundamental physics. The principles of quantum mechanics are at the heart of Willow's power. Further exploration with such devices will undoubtedly deepen our understanding of these counterintuitive yet fundamental aspects of the universe.